Yep. Hello everyone. So myself, Girish. Here I'm in the new unique session on all the softwares which we use for validation. That is SolidWorks, ANSYS, and ABAQUS. So what I had done is I'd used the same model everywhere and the same boundary condition and same material. And I just wanted to check how the softwares will help us to get the results to validate it. As the outcome, all the softwares provide the same results, that is for sure. Okay, the only thing is the mesh convergence takes place into account. So mesh convergence plays very important role to get these stress results, and the displacement will be same everywhere. Don't need to worry about it. So this video is only for educational purpose and just to explain how the software will work and how to get into the software and how to learn the softwares from the basics. Okay, let's get started. So I'll just create a model from scratch. So I'm using SolidWorks to design because in other workbenches it might take some time. Okay, that is I'll refer the rectangle of 110 and 210. Okay, and center I'll draw a circle of 41. Okay, so once this is done, you can simply extrude it up to a certain distance. You can use the mid plane for your convenience, and the distance is 10. That's fine. Okay, so this is the model which I'm going to consider for the analysis. Let's do the analysis here only for the first. Okay, you can activate the SolidWorks simulation. This has been already explained in the previous sessions. If you want to check from the scratch how to do it, and if you want to know about all the things on SolidWorks, how to deal with the simulation and all, you can refer my other videos which has been already uploaded. Okay, I'll start with a new study. It's just static one. So I'll simply do the needful, the force on this face. I'll apply the force of 10,000 Newton. Okay, I'll reverse the direction, and the material you can apply. So for the static analysis, the main thing you need is the density, Young's modulus, and the Poisson's ratio is more than enough to deal with the static analysis. So I had already created the custom materials. The elastic modulus is the 2 into 10 raised to 5 Pascal, and this one, the mass density 2850. Okay, and the Poisson's ratio is 0.3. So these are the material data which I had taken to run this analysis, and I'll use the same thing for other as well. So the picture on this face. So SolidWorks user interfaces are quite easy to deal with these all the stuffs. So you can deal with the analysis and all easily. So I'll refer the dimensions as the length, maximum element length is 3 mm and the aspect ratio 1.2 mm. I'll keep it here. So according to that, the matching is done and the results. We'll just keep it up here at the moment. Yep, so you could see the results. So it is 33.29 megapascal we can consider. Okay, or else 33.29 into 10 raised to 6 pascals. Okay, and if you want to check the displacement, it is 1.15 into 10 raised to minus 2. It is 0.01159. Okay, so this is what we got in SolidWorks. Now we'll switch to ABAQUS and we'll run the same analysis. Before that, I'll just save this model as step file so that I can simply copy the same, right? Instead of designing the same thing. Lead with the whole. I'll name it the desktop one. I'll save it as the moment. Okay. Once this is done, you can directly go to the ABAQUS. So this is the ABAQUS user interface. This is quite complex, and if you're new to this, just refer this one. So which will help you a lot to deal with the analysis, the static introduction to analysis. This is the best one at the moment. Okay. So first thing is, if you want to create the model, you can use this create options, and these all the features to create the model. At the moment, I'm not going to waste time there, so I'll simply import the model. Okay, you can go import what you want to import part, select this, and I'm going to import it from the location where I had saved it. It's the plate with hole. Okay, it will ask you for the options, so don't worry about these things. Simply just click on OK. So the model will be imported. So if you want to rotate the model, Control Alt and rotate. Okay, that is your left click mouse and drag it to rotate the model. If you want to move it, just hold the same thing and just move it like this. Quite easy. Okay, now we'll deal with the processes here. The model tab, which has all the information. So if you just follow these steps only, you can able to complete the analysis. So you can use this one, the tree, the manager tree will help you a lot. Okay, the first thing is to deal with the part. Okay, it is already here. You can use this drop down, and this you could see this is the model. In this, the important step is to define this section. Okay, meanwhile you can able to define the material as well. So if you just select the section, so automatically software will let you to define the material as well. So here it will ask you for the section definition. Select whole model, just click on done. So now I need to define the section here. Select the create section, what category it is. The model is of solid, right? So you can select the solid model. Type is homogeneous material. Just click on continue. At the moment, the material I don't have it. ABAQUS doesn't have the set of materials. If you want it, you can have the imported material data. If you want to create it, you can just simply select this create material data. So you can name it however you want. So I'll take it as steel at the moment. From the general, I'll define the density. I'll take it as 7850 as the value. For the mechanical, I'll select the elastic at the moment. Okay. There are different types you can define it. If you want to deal with the nonlinear analysis, you can use these all the plastic models. Okay, even the ductile material properties and all other stuffs and thermal properties to deal with the thermal analysis. At the moment, elastic is fine. Just select it. Okay, so here I'll define the more its modulus. It is 2 into 10 to the 5, and the Poisson's ratio is 0.3 at the moment. Okay, just click on OK to just take this material into account. So it will be automatically populated here. Click OK. Section is already selected. Done. Okay, at the moment we have done two steps, that is defining the material and adding the section. Okay, once that is done, if you're facing any confusion here, you can directly switch to this one. So we are done with the two steps. Next one is the assembly. So here you need to define the instance. Just you need to select this create instance at the moment. It will ask you for the models as well as the parts. Right now we have only simple model. Just select the part name, click apply and OK. Done. To select this first. Okay. So we have defined the assembly here. The next step is to define the step. So in this step, what exactly analysis you're going to do? So there are two procedures. One is the linear perturbation. So it will help you to deal with the buckling analysis and the frequency and other dynamic analysis as well. So at the moment, I'm simply looking for the static analysis. In the general, you can even deal with the dynamic, explicit and implicit analysis and other kinds of analysis as well. So right now, static general is okay for me. Click on continue. Okay. So these are the basics. You don't need to worry about it if you're dealing with the dynamic analysis and all. So you might need to deal with these all the factors and changing the increments and all. So let me just keep it as simple as it is at the moment. Okay, we are done with this step. So interaction. So very important thing. And ABAQUS, you can't simply select the phase and define the force. So for that, you need to create the reference point. Okay, according to that, you need to define the rigid body constraint, and you need to link that to this reference point, and then you can apply the force. That is, I'll let you know how to do that. The first thing is I'll create the reference point. So it will ask you for the references along XYZ. So I'll simply rotate the model to check how exactly the model is. Okay, it is at the center. Okay, I don't need to define the dimensions. Okay, so first coordinate is X. So X should be how much it is? 110, right? So I had taken 200, 210. So it is 105, comma. So along Y direction is 0 anyway, right? Uh, so what about the Z? So I think this is also 0 at the moment. Okay, I'll simply hit enter and you could see whether it is at exactly at the center or not. If it is not, your analysis will be different, because you won't get same analysis what you have done in all the software now at the moment. Okay, yeah, so I had defined the RP here. So next I need to define the constraint. I'll click on the create constraint. I want to define the rigid body constraint. Click on continue. Your kind of constraint you want. So I need the pin connectors. So before that, I need the reference point to be selected. Just click on this option to select the reference point, that is RP1. Click on it and just select this. Once you've done, it shows it is picked. Okay, here I need to define the pins. So I'll simply select it and I'll define the space as a reference for the pins. Okay, once that is, click on OK to complete the constraints. So we are done with this. Interactions is done. The next thing is to define the load. Okay, so first thing is I'll apply the load. So in this mechanical, so I'm going to apply the concentrated force. So what exactly this concentrated force is, it will help you to apply the load on the points. Okay, you can't apply the force on the faces because it is the concentrated force, and you can even deal with the other loading options, that is pressure and the gravity as well. So at the moment I'll select the concentrated force to deal with the loading condition, that is force. So here I'll simply select the RP, which is linked with the surface at the moment. Okay, so it will ask you for the XYZ coordinates. So X, along X I want to define it, that is 10,000 Newton. Okay, so remember ABAQUS is has the unit system. Default is SI. Okay, Newton will be the standards and SI units will be the standards. So you can refer the SI units for your reference. Okay, so keep these as 0. So if you want to define the amplitude, you can define it, or else you can keep it as it is. So for my convenience, I'll simply take it as it is. So time 1 second, amplitude will be 1 for me. Okay, not needed. You can keep it as it is. If you want to define, that is also fine. Click OK. As you could see, it is this direction. So we are done with that. So next thing is define the picture at the back side. I'll rotate the model like this, and I'll select the symmetry, or else you can select the displacement and rotation as well. Okay, I'll continue, select the face, hit on done. Here the scatter means since all the degrees of freedoms are 0, rotation and the axial. This is one way, or else you can even just simply click on this, create boundary. Instead of this, you can go with this. You can select this face as a reference, click on it. You can select these all, define 0. Okay, this is one more way. Okay, yep, so we are done with the boundary conditions and loadings, and meshing part is remaining, right? Click on the mesh. Okay, so I need to define the mesh in the moment. So for that, I'll simply click on this, double click, so it will take you to the mesh workbench. The first thing is I'll define the tetrahedral mesh, as I'm dealing with the tetrahedral mesh in the software. So I'll assign the control. So that should be for me tut. Okay, free. Click OK. The size, I'll take it 3 at the moment. Okay, click OK. This is done. So once you're done with that, click on the mesh part. Say yes. The meshing is done. Okay, so once your meshing is done, next thing is to deal with the job optimization. Anyway, is not needed at the moment. job, you need to create it. You need to select the create job, or else from this tree you can right click on it and create. Just click continue. So don't need to change anything. It will help you out with these all the options, that is precision needed or the memory usage, how you want to distribute, and general options where it should be. Okay, and then the submission. Just click on OK at the moment. So it is created. The job is your job one. Okay, simply right click on it and submit. So once you submit, it will run the entire analysis. So right now I had already ran the study before with the name of job one, so I need to override it. I'll simply click on override at the moment. So you could see on the job it shows running. So it will also indicate the stopped. If you want to result monitor, you can use the monitor option to just check how the result is processing. So at the moment I don't want it, I'll keep it here, because anyway I'm having the dialog box at the bottom. You can refer the same. Okay. Okay, as you could see, it shows that the job is completed. So at this time, from the module, you can switch to the visualize. So now you can refer this. So it shows I need to access the ODP file. So for that, you need to go to open, refer the directory. From there, just select the job one, because as I'm dealing with the same thing at the moment. Yeah, so this is the displacement, but I'm having both the deformed one as well as the undeformed one. To remove this, you can use the output data from here, sections. I don't want this, so I'll use either at this. Okay, and this is the result. 33.33 megapascal is the one mass stress. You could see this is the stress. Okay, this is the displacement, and same thing, these are the different steps. Okay, this is the one mass stress, and if I go to displacement, it is 0.01139. Okay, so we had seen there. I'll complete this one later, but I'll do one more analysis on ANSYS at the moment. Okay, so this time I'll use the static structural. You can simply drag and drop the module which you're going to work on. So once you drop it, so I do need to select the material database. So in this structural steel 7850.3, and same thing, my data is fixed. I don't need to change it at the moment. Okay, it is same. Okay, so let me jump to the project tab. So model I need to import. So I'll use the step file here. Import the geometry, browse it from the desktop. I need it with hole. Just select it. Once you're done with this, switch to the model tab, and here edit this and define the boundary conditions. As simple as it is. So you could see it is starting the new workbench. So it will take you to the one more workbench. There you need to deal with the boundary conditions and measuring all those stuffs. Yeah, so this is the mechanical workbench. So it is loading. So once it loads, we'll have the model here. The geometry is ready. Okay, the whole is ready. Default, the structure still has been assigned. You don't need to change anything. This is done. The mesh, the sizing, I'll take it as default 3, and I'll try to mesh it accordingly, generate the mesh. Nope, I need to refine it. Relevant should be fine. The angle of center, I'll keep it fine. And let me just remesh it again. Yep, this is quite okay measures for me. And this is not the tetrahedral, right? It is hexahedral mesh. So let me. Okay, it is taking hexahedral. Let me just select the method, and here the geometry is this. Method should be tetrahedral. I'll select this at the moment. Now I'll try to measure it. Let's see. Yep. So this is fine. So Exidle is the best one, but as I'm comparing the results with the all the softwares, I'm taking the same measures. The size might differ, don't worry about it. Well, the mesh is done. So next thing is to define the structural values. If you click on static structural, you'll get these tabs, or else you can simply right click on it and you can insert what you want. First, select it, select the face, apply the magnitude to be 10,000. The direction is fine. Next thing is to assign the support, that is fixed support. Rotate the model. This is the face. Here enter. That is done. So I'm done with these things. So next thing is to just extract what you're looking for, the total deformation and stress 1 minus to P. So why 1 minus? Because to deal with the ductile material, 1 minus stress is the taken into account. If you want to deal with this, why it is only 1 minus, you need to deal with the failure theories. Okay, from that you'll get to know distortion theory, the Rankine theory and all. Yep, so we're done with this. You can simply solve the model, complete process to get the results accordingly. So what is this equivalent stress and all? Very important, we need to know. So the equivalent stress is 29 here. No, displacement is fine. So, okay, I think depending upon the mesh, it is 29. The total deformation is 0.01153. Okay, so let me just compare everything. So results will be same everywhere. Remember that, don't need to worry about it. 29 megapascal here. And if I switch to the SolidWorks at the moment, if I see the mesh, let me just see this. The stresses are 33.29. Okay, the mesh is a bit fine, I believe. Yep, mesh is too fine. Okay, comparing to comparatively to the ANSYS, it is finer. And if I switch to the ABAQUS, you could see the stress results here. It is 33 megapascal. Okay, so results will be same in all the softwares with respect to static analysis, because if you deal with the mesh convergency, that is mesh convergence in the sense the stress values will be significantly same with respect to all the mesh changes. Okay, so this is 33.3 here as well. In ABAQUS as well, it is 33.3, and even in ANSYS it will be the same if I refine the mesh. Okay, so this is how you can deal with the analysis. 0.00115. So displacement is same in all the softwares which we had used it at the moment. And with respect to ABAQUS and ANSYS and SolidWorks, the stress results are also same. It is just with respect to the meshing which you are going to take that is important. Okay, so the displacement here you could see it is also the same, 0.0114. Okay, yep, so this is how you need to conduct the simple analysis in all the softwares. That's all about the session. I hope you understood the concepts, how to deal with this. Thank you all. Stay tuned.